Today we're going to be reviewing volume for prisms, cylinders, pyramids, and cones. So this is the last thing that we talked about when we were back in class before break. So we're going to work through these 4 problems here on page 13 in your note packet. We're going to actually start with the 3 down below, and we'll come back to number 7 in just a second. So just a quick little reminder, our volume formulas, I'm going to write them here up at the top. Volume for a let's try this again, for a prism or a cylinder, our volume is going to be capital B times H, where if you recall, capital B is the area of the base shape. Really important that we use that capital B there instead of a lowercase b. Lowercase b typically refers to one of those side lengths. And then H is the perpendicular height of our three-dimensional figure, three-dimensional solid. So this is different from that slant height, which if you remember on a pyramid or a cone, a slant height is what happens as you're sliding down the edge of your pyramid or the edge of your cone. We use that for surface area. Volume, we use the perpendicular height. So prisms and cylinders, the volume is the area of the base times the height, or capital B times H. For pyramids and cones, remember there is that connection between the volume of a prism and a pyramid, the volume of a cylinder or cone. It takes exactly 3 pyramids to fill 1 prism with the same base shape and the same height. So if I'm looking for pyramids volume or cones volume, it is 1/3 capital B times H. And then cylinders and cones, when we think about capital B, that's the area of our base shape. For cylinders and cones, our base shape is a circle, so it's the area of a circle, or pi r squared. So we're going to do a couple of practice problems here. We're going to start down where it says homework problems. These are not your homework problems. That's from previous years, but they are still good practice problems. We're going to start in number 1. So number 1, we have a pyramid, so we're going to use the pyramid formula up above, and I'm just going to rewrite it down here. So the volume is 1/3 capital B times H. So looking at this, my base shape, if I were to actually name this pyramid, it's not just an angle pyramid, this is actually a square pyramid because the base is that 8 by 8 square. So when I look to do capital B is the area of the square. So for us, that's going to be 8 times 8, or 64. And then the second piece of information I need is my height. Height right here, they've got that pointed out nicely for us. It's this right here, it's that pointing to the, and I know it's the height because it's got that perpendicular line down at the bottom, or that perpendicular symbol down at the bottom. So I don't need to find it, I just know that it's 10. So I know capital B, I know my height, I can go to my volume formula. Volume is 1/3 the area of my base, which we said was 64, times my height, which is 10, or 1/3 times 640, or 640 over 3, which is, if I remember correctly, 213. Now we're just going to double check. Yeah, this is, we were to be rounding, 213.33 inches cubed. Inches cubed. So if this was like a multiple choice question, or if, excuse me, they wanted, like maybe on IXL, they asked for an exact value. Here we go. You would want to put this one in. If they ask you to round, this answer right here would be acceptable, would be the preferred one if they're asked to round. Okay, so that was just pretty straightforward. We were given both sides of our base square. We were given our height, so it was a little bit of plug and check. The second one, the one off to the right here, is a little different. Same type of shape. It's still a square pyramid. I know it doesn't say square. We don't have that other side. I'm telling you that this is a square pyramid. On IXL, it's going to be a little bit more clear, or a little clearer, whether or not those side lengths are both 13 or what that base shape is. But we have a square pyramid here. But this time, instead of being given perpendicular height, which would be this value right here, you know, like we have in the first problem, we have that perpendicular height drawn down. We're not told what our perpendicular height is, but rather we're told what our slant height is, which is wonderful and it's helpful if we're doing surface area, but it doesn't really help so much if I'm looking for my volume. So what I want to do is I want to draw in that height, the perpendicular height. And then if I connect the bottom of that perpendicular height to the bottom of my slant height, if you recall, we made a right triangle. And so this side length right here, that's half of my 13, that's 6.5. What we can do is we can use our good friend Pythagorean theorem, not our best friend, SOHCAHTOA, but our good friend, a squared plus b squared equals c squared, and we can figure out what our height is. So I know my height and my 6.5, those are my two legs, so those can be my a and my b. So h squared plus 6.5 squared has to equal my hypotenuse, so 12.8 squared. And I'm going to skip some of the steps here, but we end up with that my height squared is 121.59. All I did was I skipped a little bit of the arithmetic in there. And then my height, because remember we have to take the square root of both of those sides, that's going to be 11.02678, blah, blah, blah. I don't necessarily need to write down that whole number. I am for our purposes of this video right here. But remember, we don't want to round early. I don't want to use a rounded number in the middle of my problem. I want to use the exact value as many decimals as I can. So utilizing the fact that most calculators have the answer button where you can hit, second negative or wherever it is on your calculator and you can get the most recent number that was just calculated. Or if you have one of the graphing calculators, you can arrow up and you can highlight the number that you want and hit enter, and you can take advantage of that really long decimal and be more accurate in your final answer. Okay, but there's my height. I still do need to know my capital B, which remember that's the area of the base. So for us, that's going to be 13 times 13, or 169. So then my volume is 1/3 my area of my base times my height, which is at 11.02678, blah, 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 blah. And I want to use that really long decimal if I can. And when I type this in, I can deal with that 1/3 a couple different ways. I can type it in as that natural fraction. We talked about that a little bit before we went on break, where you hit alpha y equals on those graphing calculators, and then it's your first option. You can do 1 divided by 3, and then arrow out of the fraction and then multiply by 169 times your answer. Or what you could do is you could multiply these two numbers together, and then 1/3 is the same as dividing by 3, so I could multiply both of those numbers together and get this 1,863.5266761, and I can divide that by 3. So these two numbers together, when I multiply them, give me this numerator, and then this division by this multiplication of 1/3 is the same as dividing by 3. And so if I do that, or if I multiply 1/3 times 169 times 11 point blah, 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 I should get 621.1755871, dot, 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 which if we round it to the nearest hundredth, which on this one we would most likely do, we have 621.18. And then we want to include our units, and this is volume, so millimeters cubed. And then that would be my final, try that, there we go. That would be my final volume for that square pyramid. Okay. This last one down at the bottom before we go back up and we do number 7 is a little bit different, because in this one, I'm actually telling you what our volume is, and we're asked to find x. Now, x right there, that is the radius of my cone. And if I start with just the volume formula of the cone, which most of these are all using the same formula, but the volume formula for a cone is the same as the volume formula for a pyramid. This is 1/3 the area of the base times the height. There's no radius in that volume formula. But if we think through, okay, how would I find the area of my base shape? Well, the base shape is a circle. And the area formula for a circle is pi r squared. Remember, units of area are inches squared, meters squared, feet squared. So you take your radius and you square it for area of a circle. You can also remember fuzzy wuzzy was a bear, area equals pi r squared, whatever method you want to remember. But area of my base is going to be pi r squared. So by taking my original volume formula and filling in pi r squared for capital B, I now have a volume formula that involves my radius. So what I can do is I can take the actual volume that I'm told, the volume of 8 pi, and I can take the 6 for my height. Oh, okay, that's not going to work. And the x for my radius, and I can create an equation. So I can fill in my volume. Instead of saying volume equals, I can say 8 pi equals 1/3 times pi times x squared, because x is my radius, times 6. And I know it looks really maybe a little complicated here, but there's really only one variable, my variable of x. Pi, remember, is a number. And so what I want to do is I want to solve this. So there's a couple different ways we could go about solving it. What I want to do is I actually want to multiply this 1/3 times what I can. Remember, if we keep things in terms of pi, I'm not going to multiply the pi in. I'm not going to get that decimal, and I can't multiply a number by a variable and change it. It would just be 1/3 x squared. But I do have that 6 back there. So by multiplying the right side of my equation, I get 2 pi x squared. 1/3 of 6 is 2. So I get 2 pi x squared, and then I can try and solve for x. So what I'm going to do is I'm going to divide both sides by 2 pi. 2 pi is multiplying by x squared. So I want to divide both sides by 2 pi. And when I do that, there's a beautiful thing of both 2 pi's cancel on the right. The pi's on the left cancel, and then I'm left with just 8 divided by 2, or 4 equals x squared. So x is going to equal either positive or -2, but since x is representing a distance, a length, it's a radius, I can't have a negative radius, so we would say x is equal to 2. And if I wanted to, we could double check this and we could plug this back into our formula and say, okay, what if I did 1/3 the area of the base times the height using 2 for my radius? Do I get 8 pi back? And you do. You do get 8 pi back. So this one is just a little bit, we're working backwards. We know the answer. We know parts of the formula, and we've got to find another piece of our cone, another value for our cone. So what I want to do is I want to go back up and I want to do number 7. And number 7 is remember what we would call a composite figure, because it is the mushing together of two different shapes. And for volume of composite figures, it's pretty straightforward. Find the volume of each individual piece and then add them together and you get the volume of your total figure. So this right here, this shape, this composite figure that we have, is made out of a prism on the bottom and then a half cylinder on the top. So that rounded dome right there, that's that half cylinder. So what we're going to do is I'm going to break this into the volume of my prism and then the volume of the half cylinder. And the way we're going to find the volume of half a cylinder is we're going to find the volume of the full cylinder and then just cut it in half. Okay? So for the volume of my half cylinder, we're going to start with the more difficult one first here. If I look at this, the volume for a cylinder is area of the base times the height. This is half of a cylinder, so it's going to be 1/2 the area of the base times the height. And if I think through a cylinder's base is a circle. So this is my area of my circle. This is going to be pi r squared. And if I look at this particular cylinder, If I just focus on the cylinder here, I don't know anything about that value or my radius, except if I look down here. This distance down here of 9 has to match this distance up here. So that means my diameter, that's a little hard to see there, my diameter is 9, which means my radius has to be 4.5. Okay, so not the prettiest number, but it's doable, it's usable. So this is going to be pi times 4.5 squared. And I actually do want to leave this in terms of pi for the time being. So 4.5 squared is 20.25. And then we multiply that by that pi. So the area of our base is 20.25 pi. Now I want to think about the height of my cylinder. And remember, heights for cylinders and prisms need to go from base to base. So if I look at this cylinder and I want to say, oh, this is how tall my cylinder is, that's not true. That doesn't go from base to base. That's going to go from the edge of my circle to that diameter, excuse me. That does not go from base to base. Think about your water bottle laying on its side. Think about, you laying down on your side. If you lay down, you're no longer, 6 inches tall. You're however tall you are, you stand up nice and tall. So the height of our cylinder is actually going to be this distance here, this 42 centimeters squared. So if I go and I look at the volume of my half cylinder, the height is 42. So if I do the volume, that's going to be 1/2, because remember, we only care about half of the cylinder, 20.25 pi times 42. And if I want to leave this in terms of pi, remember, we're going to multiply the 1/2 times the 20.25 times the 42. We are going to skip the pi. So by doing that, we should get 425.25 pi. And that's the volume for my half cylinder. If I go back and I say, okay, let's look at the prism. Now I can think of the prism as being its own complete separate figure and say, okay, well, if I want to look at the prism is a rectangular prism, so it's going to be easiest to think of this bottom side that we're sitting on as the base. So if I want to do the volume for a prism, volume of a prism is area of the base times the height. The area of my base is a rectangle's area of that 42 times 9. And then when I go to do my height, remember, heights of prisms need to go from base to base. This isn't going to have that same height of the cylinder anymore. Remember, the cylinder had to be laying on its side for it to be, for us to figure out what its height was. For this prism, if the bottom is my base, my height is going to be this 35. So I get 35. Now, you may think, well, that's just prism. Can't I just do length times width times depth, or length times width times height? And yes, you definitely can do that. But that only works for rectangular prisms. Any other prism, you have to use this area of the base times the height. So for consistency's sake, I'm always going to use area of the base times the height, even a rectangular prism. But you can use length times width times height if it's a rectangular base. So that 42 times 9, the area of the base, that's our 378. So multiplying the area of the base times our height, we should get 13,230. And then for the composite figure, the entire shape here, to find their volume, what we're going to do is we are going to add our prism plus the half cylinder, or the 13,230 plus 425.25 pi. And if I say leave in terms of pi, we're stuck. This is our final answer. I can't do anything more. But if I want you to round, then we can actually multiply this number out, and adding it to our 13,230, we get, if I can do this, 425.25 pi, rounding to our nearest 2 decimal places to nearest hundreds, 14,565.96. And then because this is a volume and because I was giving units, I want to give units back. Centimeters cubed. And you can already see the vast majority of our volume came from the prism, not from the half cylinder on top. But that would be our total final volume.